This video is about using the reverse chain rule to do integration. So remember that integration is the reverse process of differentiation, and when we studied differentiation we learned how to use the chain rule to differentiate composite functions. Remember, a composite function is any function where you have one function inside another function. So generally I could write that as g of x inside the f function. An example could be to have 2x plus 3, that's a linear function there, and that is inside the sine function. So let's remind ourselves how we differentiate using the chain rule. You'll hopefully remember that there is a long formal way of doing this, but we like to use the shortcut version. The shortcut version is that I differentiate the outside function and then I multiply by the derivative of the inside function. So in this case here, I'm going to differentiate the sine first, which would be cos, and then I multiply by the derivative of the inside, the derivative of 2x plus 3. When I differentiate 2x plus 3, I get 2. So I'll times by 2. And that's it. Next example. When I differentiate the exponential function, the e to the power function, I just get e to the power. And then I have to multiply by the derivative of the inside. The derivative of 5x minus 7 is 5. And that's it. The next example here, in order for me to differentiate this, I first need to rewrite it so it has a power, like this. Now I can differentiate. So differentiating the outside function, which is the power, we know to do that I'm going to multiply by the power and then take 1 away. So 2 times minus 1 is minus 2. I'm now going to take 1 away from the power. So minus 1, take away 1 is minus 2. And then by the chain rule, I need to multiply by the derivative of the inside. The derivative of 4x plus 1 is 4. And then I could simplify that a little bit. The minus 2 times the 4 is minus 8. And then I can put that minus 2 power back on the denominator like that. So that's a recap of some examples of the chain rule. Generally then, what I was doing every time was differentiating the outside function and then multiplying by the derivative of the inside function. So multiplying by a. The reverse chain rule then, what I would do is I would integrate the outside function and then I'm going to divide by the derivative of the inside function. Hence why I've got the 1 over a there. I'm dividing by a. I'm dividing by that derivative of the ax plus b. So just to repeat again, I'm going to integrate the outside function. Whatever the function is, I'm going to integrate it. My f dash is going to become f. So integrate the outside function and divide by the a. Now, important point to note here. Notice that all the examples and everything I've been talking about so far, the inside function has always been linear. There's been no squareds or cubes or sine or cos or exponentials or anything like that. It's only been linear. And that's because the reverse chain rule only works when that inside function is linear. It has to be of the form ax plus b. If it's anything else, the reverse chain rule won't work. And we will have to use a more complicated process that we will learn about in a later lesson. But if the inside is linear, if it looks like ax plus b, all you need to do, integrate the outside function and then divide by the derivative of the inside function, divide by a. So let's see some examples. Okay, first example, we want to integrate 2x plus 1 to the power 6. So I'm going to integrate the outside function. So that means I'm going to add 1 to the power. So the new power is going to be 7. I'm going to divide by the new power, so dividing by 7 would have a 1/7. And then I also need, by the reverse chain rule, to divide by 2. Divide by a, so dividing by 2, which is the same thing as timesing by a half. Don't forget, when you integrate, you should have a plus c on the end. And I can simplify that. The 1/2 times 1/7 is 1/14. Like that. As a quick check, remember that integration is the reverse process of differentiation. So I can check my answer by, if I differentiate my answer, I should get back to what I started with. So let me just check that quickly. It's always a good idea to check these things to make sure that you're correct. So if I differentiate what I just wrote down, I should get back to that original integral. So let's differentiate this. So I'm going to times by the 7. So I'd have 7/14 times the 2x plus 1. Take 1 away from the power, which is 6. I would then need to multiply by the derivative of the inside function, which is 2. When I differentiate the constant, that's just going to disappear. And we can see here that the 7/14 times 2 will be 14/14, or just 1. And you can see that we do get back to where we started from. So this is correct. Next example. In order for me to integrate this, I'm first going to rewrite this square root. I know square root is the same thing as having a power half. So I'm going to rewrite it like that first. Now I can integrate, so I'm going to add 1 to the power. So a half plus 1 is going to be 3/2. I'm going to divide by the new power. So dividing by 3/2 is the same thing as timesing by 2/3. Then, by the reverse chain rule, I also need to divide by the 3 from the inside. Dividing by 3 is the same thing as timesing by 1/3. Don't forget your constant of integration. And now we can simplify that. The 1/3 times 2/3 is going to be 2/9. And I think that's probably how I'll leave that answer. So I think that's my answer. Let's just do a quick check. So if I differentiate that, I should get back to my original function. Let's check. So I'm going to multiply by the power. I'm going to take 1 away from the power, so the 3/2 would become a half. Then by the chain rule, I need to multiply by 3. The constant would disappear. And we can see here that the 3 times the 3 would cancel with the 9 there. The 2 times the half will cancel, and we do get back to what we started with. So this is correct. Next, we're going to do a couple more examples. So in order for me to integrate this first one, I first need to rewrite this as a power. So I'm going to rewrite this as 8 times 4x plus 1 to the power minus 2. Next, I'm going to integrate this. So I'm going to add 1 to the power. Oops. So the new power will become minus 1. I'll divide by the new power. So the 8 divided by minus 1 would be minus 8. And then don't forget that we also need to divide by the 4 from the inside. So dividing that by 4. So I'll get minus 2 lots of 4x plus 1 to the power minus 1 plus c, which I could rewrite as minus 2 over 4x plus 1 plus c, like that. That's my final answer. Oops. I could check that, and I should check that as well. So when I differentiate that, So as I times by the -1, this is going to become a +2. The new power would become a -2. Then I'd have to remember to times by the 4 as well. So that +2 I had at the front times the 4 would be an 8. And you could see we get 8 lots of the 4x plus 1 to the power -2, which is what we started with. So this is correct. Last example. Now notice in this case that the denominator is linear. There's no power on the denominator there. So I am not going to do this. Oops. If I did that, if I put it to a power -1, that would be wrong. That's not how we integrate this function. Remember that in order to integrate, and we should hopefully remember this from the last lesson, if I'm integrating 1 over x, I do that with a logarithm. So just remember, if the denominator doesn't have a power, we use a logarithm to integrate that. So, integrating the outside function then, integrating the 1 over 2x plus 1 will give me a logarithm. So I would have 4 ln 2x plus 1. Then by the reverse chain rule, I'm going to have to divide by the 2, the derivative of the 2x plus 1. And don't forget the constant of integration. So I think then that my answer, simplifying my answer, then I'll get 2 ln 2x plus 1. I think that's my answer. Let's just do a quick check. So differentiating the outside function, differentiating the ln, we give 1 over. So I would have 2 over the 2x plus 1. Then by the chain rule, I'd have to multiply that by 2 because of the 2x there, which would become 4 over 2x plus 1, which is what I started with. So this is correct. And there we go. So that's the reverse chain rule. Just to recap one last time, all we do, we integrate the outside function, whatever it is, and then we divide by the a.